Good day, everybody. Today we're going to look at a little problem that might come up if you are, say, a runner and you like to go out with another person, we'll call a partner, and maybe that person's not as fast, maybe they walk. And so if you want to go a certain distance, let's say a mile, but you're much faster, you want to run a mile and meet back with that person, I'm going to ask, how far should you go before you turn around? Kind of like in this animation we see here. So first with specific numbers, let's say you run at 8.75 miles per hour and you're going to go out with someone who walks at 3.5 miles per hour. Then at some point you want to run a mile. So you want to run a mile total and you want to finish meeting your partner. So how far should you run before turning around? So there's, I'll say my speed, a little optimistic at this point, but and then partner's speed. I want to know, where should I turn around? Let's just let T be the time that we run, the total time. So the time it'll take me to do the full mile. Then we can see, distance is rate times time. So the total time I go times the rate plus the same time times my partner's rate, that's going to be 2 times D. Right? So if I were to slide this up, I would essentially have 2 times D. We also know I'm going 1 mile, so that time is that distance of 1 mile divided by mile per hour speed. So I can substitute that in. So right here, again, this will be the 1 mile. And if I put the T, 1 over 8.75 in right here, then I get this equation. I picked numbers so that it came out to a nice decimal there. So that'll be 1 plus 0.4 if you do that fraction. That's 2D, so D is 0.7 miles. So that's that. I figure I might as well generalize. So for running X miles per hour, walking Y mile per hour, and you want to run D miles. It's essentially the same math. So run X miles per hour, walk Y mile per hour. Where should we turn around? If I want to run D miles, it could be a fraction or whatever. Then again, the distance of X miles per hour times T being the total time plus Y mile per hour times T being the total time. That will again be 2D. And also X times T will be D. So T is D over X. If I substitute that in, then of course this is D. And then T is D over X. So I've got that. So it'll be 2D. If I factor out the D, it's 1 plus Y over X. And that'll be 2D. So D is D over 2 times 1 plus Y over X. And notice as your speed increases, like say speed of light or whatever, this fraction goes to 0, and so you basically have to run half a mile back, right? So if you could go the speed of mile, you would essentially run half a mile and then run back, and then you'd run the full mile. Or equivalently, if as y goes to 0, so if that person just stayed still, then you would run a half a mile and come back. Sometimes people, rather than use mile per hour, they kind of know their speed in minutes per mile. It's again the same type of math. So if you run at X minutes per mile and someone walks at Y minutes per mile, so for example, you could run a 7-minute mile. I certainly can't these days. But you're with someone who walks say at 17.5 minutes per mile. Then the distance you're going to go total is time over that minutes per mile rate. Right, that'll turn out to be the distance. And we want the total distance to be d again. So once again, t over x plus t over y, those are the two distances. If t is the total time it took. And I never solved for time, but once we know these, we could find the t, but I only wanted the d, little d. Anyway, so again, these are the two distances, so that'll be 2d. We also know the total time, just from here, is going to be x times d. So if I sub that in, x times d for the t, and then of course d is t over x. Then again, I can factor out d. Now I have x over y. So again, it's kind of the same ratio. So the d will be, so half the distance you want to go times 1 plus the ratio right here. And again, for the 7 minutes per mile and 17.5 minutes per mile, once again, that was 0.4. So it'd be 0.7 miles. And again, so here's the picture for the 8.7 miles per hour, 3.5 miles per hour. So I have it miles per hour here. If I don't loop it, then essentially the total distance in blue will be 1 mile. And that's where they meet. So in this case, it was at 0.7. I have that here. And then I guess there's another 0.3, and they meet at 0.4, turns out. So person blue went a mile. Person red only went 0.4 miles. And it was at those speeds. And if you speed it up, let's say you could do a 4-minute mile. That would be 15 miles per hour. Then you won't have to run as far. It'll be closer to the half-mile mark. So it wasn't 0.7 miles. It was actually 0.616. All right, so that's the result. Hope you enjoyed that and maybe even found it useful. Just remember, math is everywhere if you look for it. So thanks, and have a good rest of your day.